So we're going to shift gears here and take a look at virtualization. Everything I've talked about so far, whether it be SAN or NAS scale out storage, are all about creating 5 nines of availability, meaning that you have very, very highly available solution. And whether it be a SAN solution or whether it be a NAS solution, both of those have the ability to create a very, very highly available solution. In the event that you were to lose drives or things were to go offline, you're still going to maintain that data. But it doesn't broach the concepts of what happens if you lose the server. So when you look at a particular server that's responsible for servicing, a number of entities or a number of cameras that come into it, and that server is to go offline, and you're actually using localized storage for that, or you're using localized storage maybe with a SAN backend for a second tier or primary tier. When that server goes offline, more often than not, you are going to lose connectivity to that particular storage that was not only on the box, but incoming data that still needs to be recorded. If you take a virtualized approach, there are some very, very elegant solutions that will actually solve that problem for you. So while we focus on VMware, you can certainly do this with Hyper-V, you can certainly do this with KVM, you can do this with Nutanix. There are numerous solutions out there that allow you to take a look at how do I create a highly available scenario to where if a single server or an entity fails, not only do I not stop recording, but I still have access to all the data that was recorded on that particular solution. So anytime you virtualize, you are going to get a much, much more effective utilization of the resources that are associated with that particular box. Meaning that if I use a traditional server architecture, and software limitations almost always kick in before hardware does. So regardless of what VMS platform you're working with, if that particular software says we can only do 250 or 350 or 500 megabits per second, and you load that onto a bare metal server, the max capacity that you can get on that bare metal server is going to be 250 megabits per second or 450 megabits per second. What you'll see more often than not is there are numerous cycles on the CPU and memory that are not being used. On average, I'll see 60 to 40% of the actual CPU being used and roughly 40% of the memory depending upon the application. But in a bare metal or traditional server environment, you cannot get access to the remainder of those CPU cycles you're not using. So it's a limitation from the software perspective on how much bitrate I can put through, but it's also a limitation if I'm not using all the hardware that I'm paying for. When we load a VMware or Hyper-V, you have the ability to create multiple virtualized servers, and each one of those virtualized servers can be assigned CPU, memory, and data store resources within that particular virtual server. So if I'm only using 60%, the other 40% can be actually assigned out to other virtual entities that reside on that virtual server. In a nutshell, it allows you, when you go the virtual route, to more effectively utilize not only the CPU and memory, but the network cards. Almost every one of these servers is coming with 10 gig network cards these days. Yet the majority of them are well below a gigabit per second that's actually being transferred based upon software limitations. So when you start to virtualize, you start to bring in virtual machines, you can get more effective utilization of the disk, the network infrastructure underneath it, or the NIC, the memory, and the CPU, and it can treat that as a shared resource for all the virtual machines that actually reside on that, allowing you to get a lot more capacitance and throughput through that virtualized server than you traditionally would be capable of doing.